Welcome to homework.
So here, the question says that an electron is accelerated from rest through potential difference V. So what we can say from the first line is that the potential gains the kinetic energy half mv square due to the potential V, that is equal to E times V, right? So this is the potential energy given, and that is the kinetic energy. So from this line, first line, what we can say that the electron was given a velocity of how much? Twice ev by m, right? So this was the velocity given to the electron. Now what, let us continue with the question now. So it enters a uniform magnetic field where it undergoes a uniform circular motion, right? So now if it enters the magnetic field, then the force that it experiences, that F, is equal to, due to the magnetic field, that is equal to BQV. So since it has not said anything, we can consider this to be perpendicular. The magnetic field is perpendicular to the direction of uh, the velocity, right? So when this happens, then the uh, what look at the figure, then the figure shows the relation between a potential difference that was given and the radius at which the particle undergoes circulation. So if the particle undergoes circulation, so there is a centrifugal force that balances this magnetic force due to magnetic field, right? So this should be equal to mv squared by r. All right, so we are asked to find out b. So what we can say that v equals to mv by uh, for our case this q is what? Electron, right? So let me write that q is equal to e, charge of an electron, so e r. All right, so we know the value of v, right? So let us continue with this. Substitute the value of v. So m by e r times, what is v? Root under twice E capital V, that is the potential difference, upon M. Well, we can cut up some terms here, so that will give me root under twice M by E. I can put this root under till E because E is also inside root. If we cancel out, then what we have else is root under V by R. So I separated this root under V by R because we have a graph that gives the relation between Vs and R, right? So if you look at the question, let us substitute the values in here. So is equal to root under 2 times, so mass of the electron is what? 9.1 into 10 to the power minus 31. This is the mass of the electron. And what is the charge of the electron? 1.6 into 10 to the power minus 19. So what is now root under V by R? If you look at the graph here, it says that from here to this point, this is root under 40, and here to here it is 2 mm, right? Isn't it? So if you look at this point here, so this point says that at this point Vs is root under Vs power 1 by 2, that is root under V is how much? 40, right? And at the same time the radius here r is 2 mm, because from this point to this point it is 3 mm. So if we divide that into 3 parts and select the two parts, then that will be 2 mm, right? So root under V by r can be written as how much? Root under V can be written as 40, right? This is in volts, so no need to do anything with that. And r is in millimeters, so that is 2 millimeters, so 2 into 10 to the power minus 3, right? So you understood this, right? The root under V is 40 and R is 2, corresponding to this point here. corresponding to this point here, right? So if you calculate this gives out to be 0.0675 Tesla. So this gives me the magnetic field into which that particle, that is electron, enters. And this ends the solution for this question. Thank you for watching.